expansion, we're going to have to, okay, sorry, I gotta get rid of the stupid thing on the screen. All right, so this means for the corridor, we're going to have to reconnect to the existing 2-lane roadway at Watson Drive. We're keeping the existing 45-mile-an-hour speed limit. This project also will include the demolition and reconstruction of the Pantano Bridge. And then there'll also be some other improvements, including the Houghton Road and Escalante Road intersection. There'll be multi-use improvements allowing access for pedestrians, bicyclists, and future bus routes. And finally, there'll be improvements at the Sechrist Middle School. Now I'm gonna pass it off to Lee to talk a little bit more about the roadway.
Thank you, Garrett. Just as a heads up, my connection is not super great. So if I cut in and out a lot, just you'll have to bear with. The existing roadway currently is 1 lane in either direction. We are expecting the traffic on Houghton Road to increase significantly as a in between I-10 and Tancaverde. So that's one of the big reasons why the current existing roadway is insufficient. We would like the increase of traffic. This road currently does not have any bus stops. So in addition of some bus stops, as well as a bus route along the really needs an improved roadway to sustain. The existing roadway also does not have any bike lanes or sidewalks. So it is currently pretty unsafe for pedestrians as well as cyclists. So the proposed roadway, next slide, please. The proposed will have a 20-foot median and 3 11-foot travel lanes in either direction. We'll also have a 6-foot paved shoulder in either direction, and then a 10-foot path on the east side of the road and a 6-foot sidewalk on the west side of the road. And these, this increase of travel lanes is necessary to support the expected increase of traffic between I-10 and Tancaverde. So the roadway design consists of horizontal alignment and a vertical alignment. The horizontal consists only of tangents. We do not use any horizontal curves. We had a goal of avoiding overhead power lines on the road. And the vertical alignment does have some vertical curves in it. And our main goal was to minimize the borrow and attainment of new right-of-way, as well as slope easements. And our final design has a net borrow of 44,000 cubic yards. We also had a, the right-of-way to be acquired was 4.3 acres. Part of our design near Keystone, we implemented 2 retaining walls. One is on the east side of the road, and it's about 134 feet. And then there's another one on the west side of the road, which is about 1,500 feet. And this design of using the retaining wall is what we recommend. Alternatives of using soil nail walls, and as well as steeper slopes and the addition of a guardrail. We don't recommend the soil nail walls because it will probably involve closing down Houghton Road. We want to keep traffic going through the entire time during construction. And we also do not recommend the steeper slopes and the guardrail because of maintenance issues with keeping up the guardrail as people could damage it. So next, Hala will go over the traffic design for this project.
Thank you, Lee. First, I will present to you the existing traffic conditions to give you an insight about it. Currently, the existing posted speed is 45 miles per hour, and there are no truck restrictions. As for the LOS of the intersection, we used data collected from 2016 and used synchro modeling to evaluate Escalante Road intersection. And we found that during morning peak hour, the LOS is B, and the evening peak hour was A. On the right side, you can see the current lane configuration of that intersection. For safety analysis, we analyzed data collected from 2001 to 2006 for car crashes, and we found that the most frequent crashes were rear end and the most severe crashes with injuries were left turns. A total of 30 crashes and 23 injuries occurred on this segment of Houghton Road. As for the multimodal conditions, just like Lee mentioned, there are no bike routes and no transit routes. Bikers and pedestrians are using the shoulder as means of transporting, which is not safe for them. Pedestrians are also using the unsignalized crosswalk next to middle school. To start with our new design, we first calculated ESAL. We assumed an annual growth rate, annual growth of 1.05% and calculated our annual average daily traffic to be about 50,000. And our ESAL is estimated to be 11 million. We use a design speed of 50 miles per hour, and we recommend the posted speed to be 45 miles per hour. And as for the LOS evaluation of the intersection, just like the existing conditions, we use synchromodeling to simulate the traffic movements with the new traffic volumes at each approach. We also used a peak hour factor of 0.92 and an optimized cycle length of 90 seconds for all approaches. Our goal was to not have intersections operate less than C during peak hours. Therefore, we changed the left turn lanes to be permissive protected phasing to allow the queue to clear quicker. We also noted that the northbound needed an exclusive right turn lane to meet the requirement of C or better for the entire intersection. This is the new configuration for Escalante intersection on the right. During the morning peak hour, the LOS is C, and the evening, the LOS is B. In synchromodeling, we also noticed that the west left turn storage length is 100 feet, while the queue length is 125 feet. Therefore, we recommend to extend the storage length to 125 feet. As for the median locations, we designed them to be located at existing driveways and for commercial properties and residential properties for a more convenient route. For the multimodal operation, bikers and pedestrians will share a multi-use path separated from vehicles for a safer environment. Pedestrians will also have a pelican at existing crosswalk next to Secrets Middle School. We also designed bus stops for future transit routes on Houghton Road, and we also did a forecasted analysis for future crashes. Injuries and fatalities are predicted to be as low as 16 injuries per year as an average. Left turn angle and U-turn crashes should decrease with the 20 feet median. Part of our project also had to improve the traffic circulation for the school. Our plan is to implement more parking spaces as seen on the after picture on the right, and we recommend adding a new left turn lane to help reduce traffic buildup in school parking. Next slide. Currently, school buses park off-site because this area of buses does not have enough capacity. Our proposed solution is to extend the roadway and have the right lane as parking spaces for the school buses and the left lane for passing. Now I'm going to pass it on for Marco to talk about the drainage.
Thank you, Hala. Good afternoon, all. I'll be talking about the existing and proposed drainage conditions for the Houghton Road project. I just want to, hold on, let me just get my camera situated. There we go. Sorry about that. So 8 watersheds were analyzed along the length of the project for the Houghton Road corridor. Hydrologic calculations were performed using the PC Hydro online software to obtain values for the discharge on these 8 watersheds. And these watersheds were delineated on 2-foot contour interval from PIMA maps. Using PIMA maps, I was also able to approximate different watershed parameters by filtering through the different layers of the application, including through like the natural ground layers and residential surfaces, as well as impervious surfaces to be able to calculate the runoff coefficients. Also, while performing the hydraulic analysis, I noticed that for the 8 existing culverts, the 100-year flow often overtopped the roadway by a couple feet. So we deemed that we had to upsize these culverts to maintain, to improve the drainage conditions for the proposed project. We did this by maintaining an approximate headwater to depth ratio of about 1 to 1.5, and even up to 2 in some cases. This parameter just tells us about the efficiency about the culvert. And we also considered outlet protection at the downstream. Basically, the main factor was just sizing riprap aprons to prevent long-term erosion downstream of the culvert. Continue to the next slide, please. And we also had a couple improvements on the Pantano Wash Bridge. So the existing configuration for the bridge did not meet the freeboard requirements for Pima County. So we had to increase we did a couple of things. We increased the bridge by, we increased the elevation of the deck of the bridge by 1 foot. And as we also proposed a dredging event. This would help us raise the waterway area in order to decrease, to be able to bring the water surface elevation down. And since we also are trying to simulate a dredging event, I updated the value for Manning's End value along the channel to simulate the condition. Furthermore, we also need to, since we're going to be dredging the channel, a notice of intent must be submitted to the Bureau of Land Management prior to the mechanical dredging. And we also need to get the certification from Section 104, which certifies water quality from the Arizona's Department of Environmental Quality prior to the issuance of the 404 permit from the Army Corps of Engineers. And next I will be passing off to Sean to talk about the geotech.
Thanks, Marco. So our geotechnical study was broken up into 2 phases, the first of which were the 5 borings you see in the picture in the Pantano Wash. These were each 125 feet deep, and as you can see in the example on the right, most of the soil that we encountered was sand. Silty sand is the majority of all 5 borings. As a result, we used the effective stress analysis technique to find our bearing capacities. We found bearing capacities for 4, 6, 8, and 10 foot diameters, and we recommend 8 foot diameters at a depth of 90 feet. Some risks that we identified for this area is collapsible soils, since we're dealing with a dry climate and frequent flooding in the area. Also, scour and clays are not unheard of, and cemented soils in the form of caliche as well. Next slide, please. So phase 2 of our study included roadside borings along Houghton Road. We identified the soil in the area as type C, which limitations on the slope for temporary slopes as 1.5 to 1, and permanent slopes 2 to 1. And a couple risks that we identified for these borings are corrosion potential, which we found in boring B13. Also plastic soils. We found high plasticity in boring B4, and accompanied with a high fines content. Our pavement design was 7 inches asphaltic concrete over 9-inch aggregate base. And as you can see in the chart in the upper right, most of our soils were deemed acceptable according to the plasticity and the percent fines. The only exceptions were the borings B13 and B4, which, as you can see in the photos, are near the horse ranch and the middle school. Next, I'm going to hand it off to Sam, who's going to talk about structures.
Thank you, Sean. So I'll start by talking about the existing bridge on the Pantana Wash. So the existing bridge on the Pantana Wash is currently a 2-lane bridge, one northbound and one southbound lane, with very narrow shoulders for any pedestrians to cross. We have done an analysis and we found the bridge to fail freeboard requirements, putting danger of flooding and cracking in the girders. It has been determined that the bridge will not be reusable and will be removed. So in the next slide,
Maybe.
so the next slide, so we're going to talk about the bridge design. So there's many components to consider about the bridge. So a few of them are the deck design, the girder selection, span length, pier caps and foundations, and the additions of retaining walls. We're planning to add a sidewalk on the west side and a multi-use path on the east to allow pedestrians to cross safely, unlike the previous bridge. Some of our major concerns in design are geotechnical, roadway geometry, and construction feasibility. The major concern is hydraulics. Due to having such a high water surface elevation, we're proposing to dredge the channel to lower the water elevation and increase the amount of freeboard for the bridge. This allows us to minimize the raising of the bridge and maintain a better roadway geometry to avoid any major costs. The bridge also, for construction, will be built in 2 phases, where 3 lanes will be built to the east while maintaining current traffic. Then we'll get rid of the current bridge and then shift over the traffic and build the last 3 lanes. And now I'll pass it off to Abraham to talk about our possible alternative designs.
Thank you, Sam. For alternative bridge design, we came up with 3 different girder selections. The first one, as you can see on the slide, is the B2-48 ASHTO box beam, which is 33 inches tall. With this box beam, we can have the lowest D-beam, so we don't have the necessity to rise our roadway elevation than right now. Actually, we go lower. It's also a light structure, but the consequence with using this type of beam is that it's going to be mostly pricey to build these prefab beams, and also it would be required to have more spans than we actually need. We actually need more than 4 or 5 spans. For our second alternative, which is our recommended design, we'll talk about more later down on the slides. So on the next slide, please, we can see our third alternative, which is a type 6 ASHTO I-beam, which is 72 inches tall. The good thing about this beam is that it increases our freeboard, and the bad thing is that these beams are going to be so long that it's going to cost more to ship these beams into the site, and then also we'll be needing more than 2 machines to carry them out from the trucks to the bridge. And next, for our final design or recommended design, we have alternative 2, which is a type 4 I-beam, ASHTO I-beams, which are 54 inches tall. They are the second lowest D-beams and also lightweight. So we're not gonna put a lot of weight into our drill shaft, and they're also the most cost-effective beams that we have. So with this, we have a total cost of $2.4 million, including the retaining walls that we're gonna build next to the bridge. So there's no any dirt going into the wash. And we'll be using a total number of 36 shafts. So we'll be using 12 per every span. So we're gonna have 3 spans total. And then I'll hand it off to Charlotte to talk about the ambition and the stormwater pollution prevention plan. Thank you.
Thank you, Abraham. I'll be going over Envision and the Stormwater Pollution Prevention Plan. Envision is a program that measures the sustainability of a project during design, construction, maintenance, and end life. Points are earned by fulfilling credits, and an award level is given based on the number of points a project receives. The credits are broken down into 5 categories: quality of life, leadership, resource allocation, natural world, climate, and climate resilience. As shown in the bar chart on the slide, CBG engineering received the most points in quality of life and leadership. This is due to our strong community engagement and planning. We earned 372 out of the 922 possible points. With 40% of the points earned, CBG engineering was awarded a gold level of achievement on Envision. Now I will be explaining our stormwater pollution prevention plan. The SWPPP allows CBG engineering to prevent stormwater contamination, control sediment/erosion, and comply with the requirements of the Clean Water Act. The drawing on the slide is a sample page out of the Houghton Road SWPPP plans. As you can see, arrows were drawn to identify flow patterns. Sediment wattles are placed as perimeter control. They are placed where water has the potential to flow off the job site and prevent water pollution from leaving. Inlet protection are placed around the storm drains, and as mentioned by our drainage specialist, rock and inlet protection are placed on the inlet and outlets of the culverts. The containment area was placed in a high and dry location on the job site. We also filled out our SWPPP template, which identified soil types and helped us outline how we plan to protect endangered species and historical sites. Next, Rigo, our construction specialist, will go over our schedule.
Thank you, Charla. Starting with the schedule and phasing, the project construction duration will be 95 weeks and it will start on May 26th of 2020. And it's anticipated to be completely done by March 21st of 2022, giving a total of 23 months. It will start on phase 1, which will consist of building the area of Cypress Middle School during the summer, which will cover what my colleague Hala just mentioned earlier. This will be done during the summer time so that construction does not interfere with the school year. This is expected to start on May 26th and be done by the first week of August of that same year. Moving on to phase 2, it will consist of building the 3 new southbound lanes on the west, starting on the south side of the project, or in other words, from Irvington Road up north. This will allow us to build the bridge portion just right after monsoon season, and this phase will end at just south of Cypress School, and it's expected to be completed by May 2021. On the other hand, our last phase, phase 3, will consist of building the other 3 new northbound lanes. We will manage traffic by switching it to the new west lanes. And this phase will start on the north side of the project. And the reason of this is so that by the time we get to the bridge portion, it will not be during monsoon season, since we're looking to be there by early 2022. Next, moving on to easements and utilities. For easements, we will rent a temporary construction easement located at just west of the intersection of Escalante Road and Houghton Road, and we'll have enough space to store equipment, material, and precasted structures. Also, slopes and drainage easements will be needed throughout the project length. Slope easements ranging from 20 to 45 feet on both sides of the alignment, and drainage easements ranging from 50 to 95 feet located at washes and intersections. On utilities, most of the utilities are going to remain in place except for a couple underground utility TEP lines, that are located by the hillside. These lines will be relocated by a TEP subcontractor prior to building on that area. And for the other utilities, like as I mentioned, they're gonna remain in place. Next, Daniel is gonna talk about the cost estimate.
Thank you, Rigo. So the cost estimate was constructed from a list of bid items from the Pima County the Department of Transportation website. But this did not include specialty items such as the Pelican Crossing and things of that nature. Things that were given were the item number and the unit of measurement. And from there, we had to find the quantities. Ways that we did that were from analyzing bid tabs, from comparable roadway jobs. And we made certain as the construction team to not go past 5 years on projects to ensure that the quantities were up to date. Afterwards, after receiving the roadway plans, we performed takeoffs in Bluebeam, and such as concrete and sidewalk, we used to calculate that. And finally, we then had contingencies and allowances, and we used that from the other professionals on the team, such as the structures, drainage, geotech, and we received dirt work from the roadway. For the construction project, it was a total of about $10 million. And then with total, including the contingencies and allowances, about $16 million. We pass it off to Garrett to conclude our presentation.
Thank you, Dan. So in closing, this overall project is a roadway widening. The two main goals are to improve the functionality of the roadway and improve safety. These improvements are not just aimed at vehicular traffic, it's also aimed at pedestrians, bicyclists, and future bus routes. In order to make these completions, it's going to take a total duration of about 170 weeks of construction with a total cost of $16.6 million. But this is just at our 30% plan, so some changes may be coming. However, these changes will not be any of the major factors. For instance, our roadway alignment, structural plans will all stay the same. The big changes will be in adding the retaining wall designs, in adding structural details for the bridge, and adding other small details such as the landscape architect. Thank you, and please let us know if you have any questions.
Very good. I'm very pleased that this went very smoothly. You guys did a nice job of moving through it. And ran a few minutes long, but I think that's for the circumstances, it's great.
I got a minute over. That's not bad. I'm very surprised by that.
So, any of the judges, anybody have a question, please click your mic on and ask. I see Frank's ready to.
Thanks, Sal. Wanted to ask Lee, when you went through the recommendations and discussing the wall requirements, maybe it was because of the connection issue, but it sounded like you said that soil nails were not recommended and steeper slopes were not recommended. Is there a recommended approach to accommodate those?
Yes, so we're planning on doing a just a typical 3-to-1 with the retaining wall instead of doing because you could steepen it up to like 2-to-1 and then put it in guard. We don't want to do that. So the typical section shows the retaining wall option.
Okay, that helps. I just heard that there were 2 non-recommended alternatives, so I was confused what the recommended option was.
Oh yeah, sorry. I mentioned it but didn't put it on the slide.
Okay, thanks.
Words. Yeah, no problem.
Anna?
Yeah, I had a question for on the traffic presentation. I noticed that the accident reviews were from 2001 to 2006. Was there not current data available for the crashes?
This is from the data that Sal gave us.
Okay.
Yeah.
Anna, that is, SOMAS did this work and they've done all that design work. And so all the stuff that we had was old in terms of traffic analysis, but they did some updates, but they didn't feel there was enough changes that have went on there to warrant doing another full report. So what we have is the most current that was available to us.
Okay, thank you.
Can I ask something about the dredging, please? You're dredging the channel. I assume that's reached steady state in that channel as it is right now. How are you going to maintain the lower soil levels in the channel over time?
Well, we'd have to get maintenance for that. We'd have to just get the values of the current channel, well, the post dredge. We'd have to get the elevations of the post dredging event and keep record of that just to make sure we have what the water, what the elevation is supposed to be at. So as over time, if sediment comes into the to deposit again in the channel, we just maintain it by keeping the sediment out.
Any other questions? Doug, anything from you?
Yeah, I was curious on the geotech when you did the borings. Was any groundwater encountered?
No, we didn't encounter any in the 125-foot borings, and we didn't encounter any on the roadside borings as well. So no groundwater.
Okay, and the other question I have is on the construction phasing. It's great that you've planned around the summer, and then you've got phases 2 and 3. Have you looked at the earthwork at all to see that you'll be able to have the appropriate earthwork and at the appropriate locations for each phase?
Yeah, like earthwork is accounted already on our phasing. So we're gonna be working on earthwork as we are like working on our, like wherever we are. Does that answers the question?
Sorry, I lost my mute button there. Yes, thank you.
I have one more question. For the construction, did the team talk about or discuss any alternative delivery methods for this project?
Daniel, do you want to answer that?
Yes, we looked at CMAR, we looked at design bid build, and we looked at design build. We felt that the best way, and also how our class was modeled, that the best way to proctor this was through design build.
Design build? Okay, thank you.
All right. Hearing no further questions, I'll pause a second, see if anybody wants to chime in. Great job, everyone. My congratulations. I'm very happy you did a wonderful job. So you can go ahead and leave the meeting. I'm going to be leaving, and the judges will be doing some scoring, and then we're going to move on to the next team. But you did a great job.
Thank you, Sal.
Thank you.
Thank you very much.
Thank you.
Thank you.
See you soon, Frank.
Thanks, Marco.